Okay, so I would like to do number 32 and 10.3, which says I have two functions, f and g. F is this kind of big parabola thing. How would you guys describe g?
It's like a negative cosine function or something. Plus 1 maybe.
It's like some kind of shifted cosine function. Yeah. Not plus 1 though.
You got half pi plus half, right? Half pi plus half.
Yeah, maybe we got shifted up a half and then got its its amplitude compressed.
Yeah, but you could also say it's a sine wave.
Yeah, in general, it's some kind of shifted sine wave, right? Okay, so we have some kind of shifted sine wave g, some kind of parabola f, and what we're trying to do is figure out how to draw h of x is f of x times g of x, right? Okay, so when is f times g 0?
Every time g touches the x-axis.
Yeah, or at the time, or the beginning and end of that.
Yeah, so f times g is 0 when either f is 0 or when g is 0, right?
Yep.
That's the product rule?
Yes.
Zero product rule, rather.
Yes.
So anytime one of them's 0, but as it turns out, you're right that only the zeros for g seem to matter since the zeros for f coincide. Okay, so I have zeros at those spots. Okay. Now, when you're multiplying, if you multiply by 1, what happens?
You get that the same.
You get the same thing you had. Is g ever 1?
Yes, it is.
Yeah, there's kind of some times, like here and here and here, where g is 1, right?
Yes.
So when you multiply by 1, you get back what you started with, which means that at those spots, the graph is, yeah, it coincides with the graph of f.
Right.
So I get a dot here, I get a dot here, and I get a dot here. That's really me kind of tracing those up, right?
What do you mean by coincides?
So that's me thinking, like at this spot, I'm thinking about h of x, right? Well, maybe h of, let me just call that x naught, say. So I'm trying to do h of x naught, right? Which is f at x naught times g at x naught. But g at that value is what? 1, right? So that's just f at that value.
Oh, whenever. Okay, gotcha.
So what I mean by coincides is they're actually the same thing, because g is 1 there, so it doesn't contribute anything meaningful. That's cool, guys? All right, what's it do in between?
It increases.
Yeah, I mean, it kind of increases and decreases, right?
At predictable rates.
So like in here, it probably does something like this.
Pretty nifty. That's cool.
You guys with me? I screwed up one thing here. You guys see what I screwed up?
In the picture, there's 4 bumps in G, but
Okay, yeah, so aside from the fact that I didn't copy the picture down correctly. I think morally I'm correct except for this thing here. You guys see that?
because you went outside of there.
Because I went outside of F and this thing's not going to do that. Over here I had a better picture. You guys see how I kind of got that glancing glow there?
Yeah. These are cool drawings and everything.
So I think to figure that out I need something like this. Cool? Questions, things on that? How do I know it does that?
Because it's average.
I'm just kind of guessing, really, but like G is basically 1 for a little while, right? Means it's going to be about the same as F is in like maybe this little neighborhood. So that's like, oh yeah, that's like basically the same as F. And then after a little bit, I'm going to start multiplying by something substantially smaller than 1, right? So that's going to bring that height down substantially. So Oh yeah. So those aren't quite f. They might be like half of f.
Yeah.
Right?
Yeah.
And then when I get to 0, well, I know when I multiply by 0, I'm going to get 0 out. And I'm pretty sure that this has to be continuous.
This makes a lot of sense.
That's cool with that? You should be a little careful assuming that all of these are continuous. If you divide, there's no guarantee that that's continuous. All right.